Hello, students. We're going to continue with the kinematics problem solving, and we're going to work on problem sets 4, 5, and 6 today in class or at home, wherever you decide to get this finished up at. A key thing here before we begin, I keep saying that you should have a formula sheet that you're maintaining, and it is going to be imperative that you take good, I'm not asking you to take a lot of notes, but for a formula sheet, you really should be taking your time and filling in the information, similar to what I have over on the right-hand side of the screen here. See, I have the first part that we've been talking about, the kinematics, and we've gone over a couple of these formulas so far. We've gone over the average velocity, where we just take distance divided by time. We have the average velocity, where you take your two velocities, add them up, and divide by 2. We've looked at the acceleration formula. We have talked about how we can rearrange that formula to solve for the final velocity. We've even gone so far as to talk about some velocity time graphs and what the slope of that represents. We've talked about distance time graphs and what the slope represents. Well, we're going to continue with adding material to this formula sheet. Now, I'll provide a link to what I have for my sample formula sheet, but you have to understand what I would feel is a necessary thing on a formula sheet may not be everything that you would need. So you have to be academically responsible enough to put anything down that you need to. For example, on your formula sheet, if you have some troubles remembering what the units of measurement for acceleration would be, maybe you need to put that down. Maybe if we're looking through some of this and the conversion factors, you can't remember that there's 3,600 seconds in an hour, then write it down. All right, this formula sheet is going to be a resource that you can pull from throughout the whole semester, and it's going to be extremely helpful to speed things up for you and to reduce the stress that you might have when it comes to problem solving. All right, with that said, let's get on to today's stuff. I said that we're going to work on problem set 4, 5, and 6. So you do have to have this paper out, and we're going to move this off the screen in just a moment, so that way we have a little more workspace. All right, so here we go. We'll start off with problem set 4. It has question number 18. It says a car traveling at, so let's put down our givens here. We have number 18. We have a car traveling at 44 meters per second. I know that's a velocity. I don't know if it's the original or final, but it's a velocity. It says is uniformly decelerated to a speed of 22 meters per second, and it does so in a time frame of 11 seconds. Oops, let's put in seconds here. Seconds. All right. Now, since it said it decelerated, I know that this is the original and then that's the final. It's asking what is the distance that this thing has traveled. All right. Now, here's the thing here. When we're looking at this, they're not asking you for the acceleration. They're asking you for the distance traveled. So we have to figure out a formula that has that particular variable in it. Okay, so I'm going to jump over to that formula sheet so that way we can see why I'm suggesting you have a nice clean formula sheet. When it comes to figuring out which formula you need to use, you need to really rely on that guess method. See, let's look at the variables that we wrote down. We have VO, we have VF, we have T, and then we have D. All right, over to our formula sheet now. I see distance right here, but then I have average velocity, and that doesn't match up with what I have on the right-hand side, does it? So that can't be the right formula. So I'll move on to the next formula. The next formula, I see a VO, a VF, and an average velocity. Well, I don't have the distance. So what that means is we're going to have to combine these two equations right here together. All right. So how do we do this? This is where some algebra is required. If I have distance over time equals average velocity, and I know that average velocity equals VO plus VF divided by 2, can't I just say that this part of the equation equals this part of the equation? All right, now in doing that, what we can do is we can reduce out the average velocity and say that those two things are equivalent to each other. All right, now we are trying to solve for the distance. So what that means is I'm going to take the time. All right, so the time, we'll put the time on the other side by multiplying both sides by t. Okay. The t on the left side is canceled, and I end up with what would appear to be a new equation, but really it's not. We're just combining two of them together. Now, on that formula sheet, let's say that you struggle at rearranging equations. What can you do? On your formula sheet, what you can do is you can add this new rearranged equation to it. Okay, so you can put right here, if you struggled rearranging the formula, you can use that equation right there to solve for distance. All right, and that's why I'm saying keeping a good formula sheet, writing down every rearranged formula, writing down any new equation that we come up with, write it down, and then you can always go back to it quickly. All right, so we're going to use that formula to answer our question. I'm going to clean this up just real quick. It won't take but a second. Okay, so we'll have that down on our paper here. We'll go with our substitute next. You have distance equals, the VO was 44 plus the 22 meter per second divided by 2. Now that has to be in parentheses. You want to multiply only that 11 seconds after you've done the math inside of that. All right, after you've done that, you should come up with a distance of 363 meters. Okay, double check that in your calculator to make sure I have it correct. We have number 19. Now, number 19, I'm going to give you the answer for one of them, and then you have to get the answer for the second one. All right, so in number 19 here, it says a car starts a race from rest. So VO is 0. Says it's accelerated uniformly to a speed of 40 in 8 seconds. So 8 seconds is your time. What's the distance that the car has traveled? All right, so distance, meters. Now, I could go through that whole process of identifying, what variables are given to me, and I could go through and here's VO, VF, T, and D, and then I just match up the right equation that has all of them. Here's D, VO, VF, and T, so that must be the equation right here that I would use. All right, so you match the equation to the variables that you have written down in the G.U.E.S.S method. That's how you do it. So 19, we're going to use the formula right here, and we'll start substituting in the numbers. We have 0 plus your 40 meter per second divided by 2 times your time of 8 seconds. All right, you're capable of plugging in those numbers to get your answer. You provide that answer, and we will check it when you turn it in. Okay. We go to number 20. Number 20, it says a plane is flying at a speed of 150 meters per second. It's accelerated uniformly at a rate of, so that means you have an acceleration here. If it's accelerated at a rate of, we have 5 meters per second squared. It says, what is the plane's speed at the end of this? So we have velocity final at the end is what they're trying to figure out. After a time frame of 10 seconds, after I get my thoughts together. And then it has, for part B, it's a two-part deal. It says distance equals in meters here. All right, so this is a two-part question. All right, the first part of this, if it's saying what's the final speed at the end of this, then this means that that's a VO. All right, we have to figure out what equation to use. So let's go to our formula sheet, and then we're going to see how easy this is if you keep a clean one. You have VO, A, T, and you're trying to solve for the final velocity. So over in your equations, no average velocity given, so I can cross off those two. I could have the equation where we're trying to solve for the acceleration because you have VO, you have VF, T, and A, but it's not solving for VF. The VF isn't on that side. But if we take the rearranged equation, that acceleration equation, and now we look at it rearranged right here, doesn't that match up with all the variables? Yeah, so we can use that. All right, so let's use that. We'll put this down. We'll have your VF equals VO plus A times T. All right, so we'll plug in your variables. We have the VF equals 150 meters per second plus your, and make sure it's in parentheses here, just like before, 5 meters per second times your 10 seconds. All right, we'll plug that in and you get your answer. Now, I said I'm not going to give you everything. I will tell you that your final velocity, once you plug this into the calculator, I'm going to bring mine up here. We have a final velocity of 200 meters per second. All right. The second part is what you're going to have to do on your own. You have to figure out the distance. So we need to figure out a formula where you have distance, well, variables that you have currently. The ones that I've got up here on the screen, you have VO, you do now have VF, you have time, and then you have the distance. So look back at what you've done in the previous questions. You can figure out the formula that you're going to use for this one. All right, so what's that formula? And then put in your substitute, and then your solve, and then we'll call that one done. Let's go on to question number 21 now. 21 says you have a rocket that's traveling at a velocity of 88 meters per second, and it's uniform, that's a velocity, and it's uniformly accelerated to, so that must mean that the second one, the 132, is your final velocity over a time frame of 15 seconds. What's the distance it's traveled? All right. You know how to figure this one out. All right. We've done a couple of them. You go ahead and fill in your substitute. You fill in your, oh, this is your equation. That's your equation, your substitute, and then the last thing is the solve. So you fill in that information, but I will tell you that your final answer for this, if you did it correctly, this answer should come out to be 1,650 meters. And I'll even tell you what the distance for the above one should be. The distance for the above one should be 1,750 meters if you did that one correctly as well. Okay? So you have to fill out the process of how we get those. Let's go on to number 22, the last one for this problem set. So we have number 22. Says if we have an engineer is to design a runway to accommodate airplanes that must gain a ground speed of 60 meters per second. So 60 meters per second before they can take off. If the plane is capable of being accelerated at a rate of 1.5 meters per second squared, how long will it take how long will it take for them to achieve takeoff speed? And then it says, what is the distance of the runway? All right, we have a little bit of interpretation here. You're in an airplane and you're going to take off. What we have to interpret, the takeoff velocity is the final velocity on that runway. So what would be the original velocity if you're on that runway? Well, aren't you at rest? Yeah, you start off at rest and then it has to gain speed to take off. Okay, so we need a formula to figure out our time. All right, so this is where we go back to that formula sheet like I had said. Our variables that are given to us, we have VF, A, VO, and now we're looking for T. All right, over on our formula sheet side, that formula does not have A in it. That doesn't have A in it. The one right here, we do have VF, we have VO, A, and T. All right, yeah, but it's not rearranged for the T portion of it. So let's take that one off. And we go to the next thing. I have A, VF, VO, and T, and it still doesn't have the T on the side that we're trying to solve for. So what we're going to do is we're going to rearrange that equation. We'll have your A equals VF minus VO divided by T. Well, if we're trying to solve for the T, you would multiply both sides by T. Okay. That means that the T gets reduced out. Then we can divide both sides by A. That will reduce the A on the left side, and you have, again, a rearranged equation. It's not a new one, it's just rearranged. If you have troubles rearranging equations, I'd suggest that you write it down right there. See? If you have it written down, now you don't have to rearrange the thing every time that you go to solve for something, solving for the time, and when you're given those extra variables. Right? So let's clean this up just a little bit. Get this out of there. And there. Okay. So we're ready to substitute in some numbers. You have time equals. Make sure that you put the final velocity in here first. All right. So why put in the final velocity first? Because we're getting the difference between the two. We're not adding them up. We're taking the difference between those two. We divide it by your acceleration. Okay. So we're ready to put in your numbers. You have 60 divided by the 1.5. You should end up with a time of 40 seconds is what it's going to take on the runway. For part B, I want you to fill in the rest of this. All right. And if you do that correctly, what you should end up with is a distance of 1,200 meters. Okay. What formula are you going to have to use? Well, you're going to have to look. You have VF, you have VO, you now have T, and you're trying to solve for D. Look at your formula sheet and figure out which one has those variables in it. On to problem set 5. So we have problem set 5 is what we're going to work with. And problem set 5 is going to require us to derive a new equation from the ones that we've written down so far. So we have question 23. You'll see exactly what I'm talking about here. It says that an airplane starts from rest. VO is 0 then. It says it undergoes uniform acceleration of 3 meters per second squared. And it does that for a time frame of 30 seconds. It says, what is the distance that this thing is going to travel during that time frame? All right. You can do one of two things here. You can keep a good formula sheet and not have to go through the whole process of deriving equations, or you can learn how to derive equations and, work it out as you go. So in this particular case, you can kind of fast forward to the actual formula if you are willing to keep a good formula sheet. If not, follow along with me. All right. So we have our formulas right now. You have distance over time is average velocity, and that's the equivalent to this formula right here. And then we have the acceleration formula, where it's VF minus VO divided by T. All right, what we have to do is we have to combine all three of these equations together, because the givens that we have here, you have VO is here, VO is here. You have A is right here. You have time is here, time is here. And we're trying to solve for the distance, that's there. What we have are two undesirable variables that are not given to us. We do not have the average velocity, and then we do not have the final velocity. So those two variables that are not given to us, that's how we're going to tie all of these together. Now the first one is very simple. When we're looking at combining your two average velocity formulas, it's pretty simple, because all you have to do is just erase this, and lo and behold, you've got that. Okay. Now, the second one, when you're trying to get rid of this final velocity, you do have to make sure that you rearrange this guy first in order to have the final velocity on one side of the equation before you can start. All right, so if we rearrange this, which I have shown you already how to do that, what you're going to end up with is VF equals VO plus AT. All right, so that's been rearranged from before. Now, just like we did a moment ago, we substituted out the variable that was undesirable. See, take a look. If I know that VF equals this formula right here, and VF represents that in that equation, then I should be able to just get rid of this and plug that into its place. See how that works? Okay, so now all of the variables that are given to me in the problem are now in the equation. And we can simplify this for our formula, and this is where I'm saying if you do this, it's going to make your life a little bit easier for that formula sheet. All right, we're trying to solve for the distance. That means I want to get this time out of here. So I have to multiply the time by both sides. So I'm going to go distance equals, and this right here, the VO is 0 from the problem. So if we have 0 plus 0, is it going to do anything? No. So I'm going to get rid of that altogether, because that equals 0. I'm going to put A times T divided by 2. Now, the T, in order to get it to the other side, you have to multiply both sides by T. Okay? I know it's getting a little crazy, but it'll all work out. So when you multiply both sides by T, you'd have AT squared, T times T. All right? So this is our new equation that we can put down, but we can only say that if VO equals 0. All right, you're going to notice that part right here, this equation, I have that in my formula sheet, and it is right here. See, now you can go through, and I even have the rearranged portions of it here for later on. That only is true if your original velocity was 0. If your original velocity is anything other than 0, you can't just get rid of the VO like I did. All right? So if you wanted to skip that part, right now is where you need to pick up. Okay? So we have our formula. I'm going to clean this up first before we move on. Delete this stuff. And we're going to put in that new derived equation. So you have AT squared divided by 2. And we're going to substitute in our numbers now. You have distance equals, the A was 3 meters per second squared. Our time was 30 seconds. But you need to make sure you follow the proper order of operations, because when you do this math, you're going to have to make sure that you square that time first before you're able to do anything else. So we need to square that thing first. All right, square that time. And we have now, you've got your, do the math of this, we got 30 squared times 3 divided by 2. You should come up with 1,350 meters if I did it right. Okay. So let's go to number 24. Number 24, there's going to be a little less help with this one. Number 24, you have a jumbo jet lands on a runway traveling at a velocity of 88 meters per second. And, yeah, we'll put VO. I think that's going to be VO. And is decelerated uniformly for a time of 11 seconds. It says calculate its deceleration. So meter per second squared. And then it says what is the time, or I'm sorry, distance traveled from the runway. Now we have to read into this a little bit, because it says the airplane landed on the runway and it decelerated to rest. So that means your VF here is 0 meters per second. We're ready to figure out a formula. Well, your formula that's going to fit with this one, you have VO, you have T, VF, and you're trying to solve for the A. Well, if we take a look at our formulas, VF, VO, T, and A, that's a perfect match. No rearranging of the equation whatsoever. So you have VF minus VO divided by T. Then we plug in the variables. 0 minus 88 divided by 11 seconds. So why is it important to always make sure that you follow the formula? You put VF minus VO because this comes out to be a negative 8 meters per second squared. The negative means that you're slowing down. Okay, you're decelerating. The second part of this is the distance. The distance now, be careful. Can we use the AT squared divided by 2? No, you cannot, because VO is not 0. All right, so what we have to use here is the other equation that had distance in it. Distance VO plus VF divided by 2. On to question number 25. 25, we have, let's see, it says the Tokyo Express is accelerated from rest. So that tells me that number 25, I can start out VO as 0 because it's starting from rest. And it's going to accelerate at a rate of, so that's acceleration, 1 meter per second squared for a time of 1 minute. It says, how far does this travel? So distance equals question mark. And we're going to put meters. Now our formula, based on the variables that we have, that means that I have this VO is 0, right? we have A, T, and D. That means from my list of equations, VO is 0. I have A, T, and D. Then that's the one I want to use for this. All right. So we'll put that in. AT squared divided by 2. And I'm just going to put a side note. You don't have to do this. VO was 0. All right. So this guy right here, since that equaled 0, VO was 0, that's the only time that we can use this equation. All right. We'll plug in our numbers here. We have distance. The acceleration is 1 meter per second squared. We go divided by 2 times we have 1 minute. All right, but before I go any further, notice that our units of time don't match up. You have minute and then you have seconds. So let's be wise about this. All right, you have to have these units of measurement matching up for them to cancel out correctly. So let's, instead of putting in minute, let's put in the equivalent of 60 seconds. All right, now if you put in the 60 seconds, now the units of measurement are going to cancel out correctly. And what you should end up with is an answer. If I put this in, you have a distance of 1,800 meters. Okay. All right, 26, since we've gone over a couple of these, 26, I'll write down the givens, and then you have to fill in the information. It says a car starts from rest. So VO is 0, so you know automatically that it might be that one equation that we just derived. We have a distance of 200 meters, and then we have a time of 5 seconds. And it says, what is the acceleration? Acceleration equals question mark. All right. Now, I said that I would help you get it started. So in that equation now, I know that our variables, I have the distance, I have the acceleration, I have the time, and VO was 0. I just have to rearrange that formula to solve for the acceleration. So that means I'm going to multiply both sides by 2 and then divide by t squared. So rearranged, this is the formula rearranged. Okay. So I'm going to plug that in to this. Acceleration, that kind of looks like a D for distance. We have acceleration equals 2 times the distance divided by the time squared. All right. You put in your substitute and then your solve, and what we should end up with, all right, after we do this, we should end up with a meter per second squared unit. You tell me what this is, and then you provide all of the detail right here for this. Okay? We'll go to number 27. Number 27 says, in an emergency, a driver brings a car to a stop. So that means that they were traveling at a speed and they're going to come to a stop in a time of 5 seconds. If the car is traveling at a rate of 38 meters per second. Now I'm putting that as VO because it was traveling at that and it's going to come to a stop. It says, what is the car's deceleration? So acceleration equals question mark. And it has a part B, how far does it travel? Distance equals, and that will be in meters. All right, now I'm going to leave it to you to figure out what your two equations are. You have to figure out what your substitutions are, and then you have to figure out what your final answer is for the bottom. I'll tell you what you should end up with. Your answers would be a negative 7.6 meter per second squared for that answer, and then your distance should be 95 meters. So what you're responsible for is the substitute and the solve, all right, for both of those. We're at our final problem set 6. Now, to start with this, I'm going to tell you ahead of time that you are going to need to use these two equations right here. If you want to see how we derive those two equations, then I'll show you that real quick. If you just want to get the formula down, then go ahead and skip to the point where we actually show the work. All right. So to start us out, we have to combine the formulas, the distance over time, the average velocity, where we're adding them up together, and then we need to combine those two with your acceleration formula here. Now, in the problems, what you're going to see is that there are common variables that we need to substitute out. So the ones that are highlighted are the ones that we need to get rid of. All right. So the first one is very simple. We can combine these two equations together simply by erasing the v, the average velocity, in between them. Okay. Now, since we're trying to substitute out the time, I don't want to leave this in the denominator. So I'm going to put this over here, and we had that formula before. On the right-hand side, if I want to combine these together, I need to get rid of, substitute out the time. All right. Well, I don't want the time ever when I'm trying to combine equations together. I never want it in the denominator. So I'm going to multiply both sides by time, and I'm going to get the a here. If I get this correctly, I want the acceleration on the bottom like this. Okay, so I would divide both sides by a. All right, when we combine these two equations together, just like before, we want to substitute out the undesired variable, the thing that doesn't fit. Time is what I want to get rid of. So if I go like this, see, look, if the time is being multiplied by VO plus VF divided by 2, and I know that time equals VF minus VO divided by A, I can substitute those together right like this. And now, if I erase the time, you have your new equation that has been derived. Now, we will simplify this. All right, in our problems, either VO or VF is going to be 0. And let's just pretend at first, if VO was 0, if I have VO as 0, is it going to make any difference when I add VF to 0? No, it's not. So what we can do is, if we say this, if I remove these and I say VO equals 0, I can reduce it out of the problem. All right. Our numbers here, if we multiply these two together, on the top, what you end up with is, if you multiply VF times VF, you end up with VF squared. And then on the bottom, if we multiply those two together, you end up with 2a. All right, so that is, I know that's kind of a crude way of showing you, but if you write down your equation sheet, the VO equals 0, then you can use that formula. Then you're not going to have a problem with rearranging things. And likewise, if we change this up and we said VF was 0 at first, then we would just change this to VO squared divided by 2a. All right. So let's get on to the work and actually apply this. So we'll go to number 28 now. 28, problem set 6, says that a plane accelerates from rest. So VO is 0 meter per second, and it accelerates at a constant rate of 3 meter per second squared. And it's going to cover that distance of 500 meters. It says, what is the speed after traveling this distance? So we're trying to find the VF here. All right, this is where that formula is going to come in handy. See, when we look at our formula sheet, I'm trying to find the formula that has VO, A, D, and VF in it. All right, so if we just take a second, just process of elimination. There's no acceleration, no distance in any of those. so I can't use those. No acceleration. Here, no VF. So right here, this is solving for VO, so that can't work. But in this case, see how I have the VF? That's what I'm trying to solve for. I know A and I know D, and I know VO was 0. So that must be the equation that I'm going to use for this particular problem. All right, so let's put that in. You have VF equals, it says the square root of 2AD. We just rearranged your, you had D equals VF squared divided by 2A. So we rearranged that. We multiplied both sides by 2A, took the square root of VF. That's how we got that. Or you just simply remember to put down some good formulas on your formula sheet. Okay. Let's plug these in now. You have VF equals the square root of 2 times 3 meter per second squared times your distance of 500 meters. If we plug that into the calculator, what we're going to end up with is, let's make sure I have this correct now. We should have 54.7 meters per second. All right, now I want you to double check to make sure you're doing this correctly. In your calculator, what you would have to do is you'd have to press the square root button, parentheses 2 times 3 times 500, like that, in order to get this correct. Okay. We'll go to 29. 29 here, it says that we have a decelerating of a plane. A decelerating plane at a rate of, so we have acceleration is 8 meters per second squared. Now, if it's decelerating, what is that value? Negative. Negative. The plane is going to come to a stop, so that means that the VF is 0 meter per second, and it has the distance of 484 meters. How fast was the plane going before it came to a stop? So we're trying to find the VO here. VO equals question mark. All right, formula time. If you ever see VO or VF being 0, just look for those statements. All right, so we had this one right here, VO was 0. Well, we're trying to find VO, so that's not it. If we go down below, if VO is 0, all right, if VF is 0, sorry. If VF is 0 right here, then I would use that formula. So I'm going to have the square root of 2AD here. All right, so let's plug that thing in. We'll have VO equals the square root of 2 times negative 8 meter per second squared times 484. Now, the negative sign inside of there is not going to work out. I think it might come up with an error, so just be aware of that. Just get rid of the negative when you're doing the math of it. And what we should end up with is our initial velocity should be, I believe it should be 88 meter per second. All right, we can check that with the calculator, and then you can see how this is supposed to be typed in too. So we go square root, parentheses, 2 times 8 times 484, close it up, and you end up with 88. All right. Let's go to number 30. Number 30 here. Number 30 says that you have a box falls off of a tailgate and slides on a street for a distance is 62.5 meters. Friction decelerates the box at a rate of, so we have that negative 5 meter per second squared. Negative because it's slowing down, right? It says, what was the speeds truck before the box fell off? So we're trying to find VO, meters per second. Now, we have to interpret this a little bit. The box, as it falls off of the truck, it's eventually going to come to a stop. So our VF here we know is 0. All right. So if you are trying to solve for this, I want you to figure out what your equation is going to be. You're going to substitute in the variables. And if you did that correctly, your answer for question number 30, the truck should be going 25 meters per second. All right, so you've put in the other 2 pieces of the puzzle that are missing, and then you'll have your answer. We'll go to number 31. 31, we have a plane is flying at 40 meters per second. It's going to be a velocity. Velocity. It touches down on a runway and travels a distance of 100 meters before stopping. So our VF is 0. It comes to a stop. So that was VO. It says, what is the rate of deceleration here? All right, so our acceleration is, all right, and at this point, what I want you to do, I'm not going to help you out with this one. I want you to look through your formulas. I want you to figure out what equation to use, substitute in your variables, and if you did this correctly, number 31, you should end up with a negative 8 meters per second squared. It's going to be slowing down to a stop, okay? We have number 32, the last one that you have for today. Number 32 says that suppose you're driving along a highway at a speed. So you have 32, you have 45 meters per second. And it says that your best deceleration of your brakes produces an acceleration of negative 4.5 meters per second squared. Why negative? Because it's slowing down. What's the minimum distance? What's the minimum distance that you need in order for this car to come to a final velocity of 0? All right. So what I want you to do is look through those equations, see which one matches up, go ahead and substitute in your variables, and if you did everything correctly, number 32, you should end up with a distance of 225 meters. All right. When everything is said and done, you need to make sure that you have your name at the top of your paper. Take pictures of each of the pages and then submit it to Schoology. If you have any questions, please make sure that you ask, whether it be the email or just ask me directly.